Welcome to episode 240 of Astrophiz. I'm Brendan O'Brien, and we acknowledge Australia's first astronomers, the traditional owners and custodians of the land we are on. This episode is produced on Yorta Yorta, Pangarang and Wuyakali country. Join us as we fight for a greener future as we sit down with the world's leading space scientists to discover exactly how our universe works. And right now I'm in remote Outback Australia. 9.5 hours driving north from Melbourne, 6 hours east of Adelaide, or 13 hours drive west from Sydney. You choose. We took the 9-hour drive and here we are in Silver City, the mining town of Broken Hill, to meet Australia's most famous Outback astronomer, Trevor Barry. Hey Trevor, how are you?
Very good, thank you, Brendan.
Trevor Barry is an amazing planetary observer whose background data from Broken Hill, New South Wales, has earned him international recognition within the professional planetary science community. He is also the author of the fabulous book Outback Astronomer, which I highly recommend to anyone fascinated by the reality of independent scientific discovery. Now, Trevor did not follow a traditional academic path. Instead, he transitioned from a long career in mining to building a world-class independent observatory. And for over 2 decades now, his rigorous high-cadence tracking of Jupiter and Saturn has provided professional astrophysicists with continuous data that major institutions simply cannot replicate due to limited telescope time. His meticulous observations of Saturn's atmospheric storms have directly supported international missions, including NASA's Cassini mission to Saturn, and in 2022 earned him the prestigious Berenice and Arthur Page Medal from the Astronomical Society of Australia, followed up by the 2023 Walter H. Haas Award from ALPO. Today, Trevor joins us to discuss his book, the technical demands of high-resolution planetary imaging, his personal relationship with NASA, his tours up to Keck, and what it takes to build a bridge between an ambitious backyard setup and the world's leading space agencies. Trev, welcome to Astrophiz.
Thanks very much, Brendan, for asking me to be on Astrophiz.
Excellent, Trev. Now, you have a truly fascinating background, but before we dive head first into the night sky, can you share with us that early aha moment when your focus shifted forever from the ground beneath your feet up to the planets above?
Well, Brendan, so many serendipitous things have happened in my life that have tend to focus and change my direction. Like most of Earth's population, I never looked up. I had no interest in the night sky whatsoever. And many years ago, whilst working on the mines as a tradesman, an apprentice came through my department and he and his dad had built a telescope. And he asked me if I'd go and check out his telescope. And really I wasn't that interested in doing so, but he was persistent, and one night I did go to have a look at his telescope, and the first thing he showed me was Saturn. I couldn't believe that I could see almost a textbook image from this homemade telescope. It was an 8-inch Newtonian reflector. It was on a German equatorial mount. That meant nothing to me at the time, but my background was engineering, and from that perspective, it was a terrific piece of kit. And I was most impressed with what they'd put together. And it's something that I just had to get into. That night, instead of being there for a short time, I was there for an extremely long time, and he started pointing out these little patches of fuzz. They're there every night, Brendan. No one sees them. I never saw them. But they resolve into star clusters, emission nebulae, planetary nebulae, all manner of other deep sky objects that I'd never realised existed. It's something I had to get into.
Fantastic. Now, moving from a career in mining to building your own state-of-the-art backyard observatory in Broken Hill, that's an incredible leap. But apart from some issues with your gorgeous and adorable wife's jacaranda tree, what were some of the steepest learning curves or unexpected hurdles that you faced when you were setting up your equipment?
Well, initially, Brendan, I visited our local municipal library where I found a book on Newtonian telescopes. And this was what I was going to build, a Newtonian telescope, and it had to be on a gem, on a German equatorial mount, because I wanted to track the objects that I was observing that I would later get into astrophotography with. What was I going to use for a telescope tube? I worked out what size telescope I wanted to build. I built initially a 10-inch Newtonian reflector, so I needed a tube at least 12-inch diameter. What would I use? And I looked around, and I ended up sourcing a length of plastic storm water pipe. So I constructed it on a pier. I welded 3 fabricated legs, and we had a back lawn, which my wife very much admired, her back lawn. I got the post hole digger out and I sunk 3 holes into the lawn. So I had 3 holes and they were filled with concrete, such that when I put my mount on those 3 concrete bases, if the centre of each fabricated leg, the end of the leg, was in the middle of the concrete pad, then the polar axis was aligned very closely to north-south so that I could track stuff. The telescope lived in a bedroom in our house. I welded brackets onto the front 2 legs of the telescope mount and slotted 2 lawnmower wheels so that I could lift the 3rd leg and wheel the mount like a wheelbarrow, not with a telescope on it. And this worked famously until the day happened, the fatal day, when, as I was rolling the telescope mount out from the back veranda onto the gorgeous and adorable's back lawn, it bordered her rose garden. Very proud of her roses. She can grow anything, you know. And the moment came when I lifted the leg that I was using to trundle the mount out too high, and Newtonian physics took over and launched me over the top into the rose garden. Well, the roses weren't damaged, but I was. And this was the seed planted that I had to have an observatory to house this telescope instead of trundling it out to and fro.
Fantastic. Thank you, Trev. Okay. Now, Broken Hill is famous for its clear outback skies, but it also presents unique environmental conditions. How do the local climate and atmosphere shape your nightly observing sessions? Do you look forward to winter for better viewing?
Well, funnily enough, young Brendan, not really. Routinely, my best seeing is March, April, May. That's the best time of the year for me. That said, I've collected good data in every month of the year. We're a long way from the coast, so generally we have low relative humidity. And if you look at the weather charts, as the weather systems cross our continent west to east, often the high pressure systems track inland, and quite often they pass over Broken Hill, over my observatory, which tends to push the jet north and south, and I have stable air over the top. So, and also another thing, it's the desert, the outback of Australia. It's flat, so there's no mountains or anything to the west that would delaminate the airflow. Like our atmosphere, people don't realise this. Earth's atmosphere is layered. So wind shear is bad news for aircraft, bad news for affecting astronomical seeing. Well, the lower layers of Earth's atmosphere, the airflow can delaminate. If you were a sailor, you'd understand this. So we tend to get laminar flow with the airflow, the low altitude airflow coming from the west, because there's no structures that can cause the airflow to delaminate. So again, another plus for Broken Hill. Our community is only a small community. Light pollution isn't an issue at all. You know, the number of times I've had professional astronomers come here, they can't believe that with the light of the new moon in the sky, the small and large Magellanic Clouds are absolutely naked eye. On a good night out here, you can wander 5 minutes out of town, nearly in any direction, stand on a claypan and look nearly to the horizon before you can see a star scintillate, before you can see a star twinkle. And not only that, the light of the Milky Way, if the Milky Way is over the top, that time of the year when it is, then the light from the Milky Way means that your body throws a shadow on the claypan. It's just a terrific place to do what I do.
Amazing. Look, okay, right now we're inside your observatory and I'm looking at your workhorse, your rig. Now, for the propeller heads in our audience, and we know we've got a lot of them, could you tell our listeners what I'm looking at right now? My jaw has just dropped. Can you talk us through your current telescope setup here, the optics, and how these amazing images you capture, how they are sent to your computer for high-resolution planetary data?
Well, the telescope that you're looking at, I designed and built specifically for high-resolution imaging of the planets. Now, preceding the telescope you're looking at, when I went from the 10-inch scope that I first built, when I only had a single-story observatory, but big is always better, so I went 2-story, and I wanted a bigger telescope, a bigger primary mirror, and I actually sourced that by buying a 16-inch Meade Dobsonian telescope. I didn't want a Dobsonian telescope, I just wanted a big mirror. There were major problems with the Meade for high-res planetary imaging. The primary mirror cell was just made of particle board and only had 3 supports supporting the primary mirror. Rubbish. So I threw that away and I built my own primary mirror cell that was made of heavy walled inch square tubing, welded, fabricated, and built a 32-point primary mirror cell. So instead of the primary mirror only being supported in 3 places, it's a big mirror, it was supported 32 places, so far better support. Back when I was using the Meade, I used their cardboard tube, which is very heavy. My ultimate telescope is an aluminium tube, much lighter. A friend of mine, very good friend, been very supportive since I found him and he found me, Anthony Wesley. June 2010, Anthony Wesley came for a visit and he brought his telescope with him and he set up on the concrete pad where my observatory used to be in single-story format. Now this was a custom-built telescope with an aluminium tube and custom optics. Newport glass for the primary mirror, Antares optics for the secondary mirror, and we're both imaging. He'd come up, check out what I was doing, I'd go down, check out what he was doing, and I was so taken with the difference in quality between the custom-made optics looking at the same target, be it Jupiter, Saturn, what have you, compared with the production optics that came with the Meade. And it was then and there that I formed the opinion that I would build my ultimate scope with guidance from Anthony on how he went about doing it. So the scope you're looking at, the primary mirror, was sourced from Newport Glass in California. So when you order that primary mirror, you specify the curve that you're after. I specified f4.5. There's one master mirror maker in Australia, Mark Suchting, was then in Sydney. And so I went through Mark. So I placed the order with Mark. Mark sourced it from Newport Glass. The thing about their primary mirrors is, unlike the situation with mass-produced mirrors where someone's trying to, a production line of producing mirrors, the primary mirrors produced by Newport Glass, they stay in an oven for an extended period of time, a couple of months. The cool down period lasts over an extended period, so they just don't cast it and take it out the oven. They let it cool down over time, so there is no chance of having air bubbles form in the Pyrex through it cooling down too quickly. So it's a quality primary mirror. So that came to Mark Suchting. He put in the best part of 6 months hand finishing that curve. There's nothing perfect in this world, however, it's a stunning primary mirror. Now, telescope secondary mirrors, flat elliptical mirrors. The spec for a telescope flat elliptical mirror tends to be around a 1/7 wave tolerance. So that is the difference between the highest peak and the lowest trough on that flat elliptical surface would be within 1/7 of one wavelength of light. Well, Anthony's secondary and my secondary was sourced from Antares Optics, again in California, and they're 1/30th wave flat elliptical mirrors. All these things go together to provide the possibility of a better result. Also, as the ambient temperature drops through the night, the temperature of the Pyrex will drop, but it doesn't catch up. So this is especially critical in the summer, in the warmer months, especially when imaging before midnight. So I built a Peltier cooler for my primary mirror. So that has the cold plate, and one side of this Peltier is in direct contact with the cold plate, and in direct contact with the hot side of the Peltiers, there's 3 of them, is a very heavily thinned heat sink. There's a polycarbonate barrier between the cold side and the hot side of the Peltiers. There's 3 fans that blow air directly into that thinning of the heatsink, the hot side, and so the air is then distributed out either end. There's a foam barrier around the primary mirror so I can't get feedback of that hot air back into the cold side of the Peltiers, and there's 3 internal fans that distribute air from the cold plate onto the back of the primary mirror. So I would run that for 2 hours in the afternoon that I was going to image that night. And then when I shut it down, it's not just a matter of shutting the whole thing down. I shut the 12-volt power down to the Peltiers, leave both sets, internal and external fans, running for another half an hour to equalise the temperature of the cold plate. And then it's about another 20 minutes, 30 minutes before I would image, because I've created currents inside the tube. So the tube, it's an aluminium tube because aluminium mirrors ambient. Anyone who parks their car outside, then some mornings you go outside and there's all condensation on your bonnet. The steel has gone below dew point and it's condensed moisture out of the air, and you've got condensation on the bonnet of your car. A steel telescope tube can actually go below dew point and do the same thing. The relevant point is that if it's at a different temperature to ambient, if it goes below ambient, then it can generate things called tube currents that run up the inside surface of the telescope tube. Now, Using a telescope optically with an eyepiece at 100, 200, 300 power, that is totally irrelevant. But imaging at 2000 power, everything between the face of the primary mirror and the object is magnified. So, the boundary layer of air that's in contact with the face of the primary mirror has to be the temperature as near as possible of the mirror. Because if it's not, little currents will be generated in the boundary layer of air. I would magnify that. If there were tube currents, I would magnify that. All these things we have control over. Everything that I can do, everything that's in my control to make my imaging better, I do. I'm a pedantic bastard.
And that is Science 101, 201, 301 and into Masters. Thank you very much, Trevor. Now, could we reflect on that moment back in February 2008 that led to your first contact with Dr. George Fisher and his invitation to support NASA's Cassini RPWs, their radio and plasma wave science team, which began your long-standing involvement with professional research, including Professor Agustin Sanchez La Vega?
Yes, well, Brendan, so 2008. Yeah. 2008, I'd finished my degree in March 2005. And by this stage, I think in 2000, Professor Fred Watson, Dr. David Malin had visited my observatory. Fred's been twice. So they knew what I had, my enthusiasm, so to speak. So I had professional contacts following the work that I'd done at Swinburne in doing my postgraduate degree. I was imaging Saturn just with the most basic kit, a Philips 2U cam, just a webcam. And on the 23rd of February 2008, and there was this small white spot in the southern hemisphere of Saturn. I hadn't seen anything like that. And looking at one of my university texts, Universe, Kaufman and Hoffman, and that told me that in the previous 200 years there had only been 5 electrical storms seen on Saturn that were visible from Earth. So I knew that what I was looking at was important. I contacted Fred and David, and David got back to me and sent me a link to go to Cyclops, Cassini Imaging Central Laboratory for Operations. Cassini had launched in 1997, went into orbit at Saturn in 2004, so I knew Cassini was there. And I thought, well, if they don't know about this storm, they need to know. So I trawled the NASA websites looking for any update on something that Cassini had found, and I couldn't find anything, which is why I contacted Fred and David. So following my contact with Cyclops, Dr. Georg Fischer, he's an Austrian, then at the University of Iowa, and he was on the Cassini radio and plasma wave science team. So the nuts and bolts of that is, if you have a radio turned on and there's an electrical storm near you, whenever there's a bolt of lightning, you hear static on your radio. So that's all the data that Georg was getting from his instrument on the spacecraft. The inputs were 3 whip antennae, and those whip antennae picked up the radio data from the electrostatic discharge lightning within the atmosphere of Saturn. So Georg got back to me, said he knew there was a storm at Saturn, that in fact it had commenced in late in November the previous year, so late November 2007. But up to the point that I sent my data into NASA, Cassini had only imaged the storm once. So you must understand that there are multiple instrument packages on the spacecraft, and each one of those instrument packages, those people had like time allocation on the spacecraft. So Georg just couldn't say, look, I want Carolyn Porco to image Saturn for me to see where the storm is. So the data that Georg got never even told him what hemisphere the storm was in. It only told him that there in fact was an electrical storm happening. So to understand this, we have to go a little bit deeper. So there are three cloud layers at Saturn. So there's an upper cloud layer of ammonia ice particles, an intermediate cloud layer of ammonia hydrosulfide ice particles, and then a third cloud layer of water ice particles. They're to a depth of about 300 kilometres. The same three cloud layers exist at Jupiter, but at Jupiter they're compressed to a depth of only 50 kilometres. That's why Jupiter is much more dynamic. It's a massive object. These ice particles in the water ice cloud layer have potential energy. They're just sitting there, they're doing not much. From time to time, a poorly understood heat source drives material from below the water ice cloud layer upwards. So these ice particles are surging upwards at about 100 metres a second. So now they're rubbing against one another. Kinetic energy. So they build up, charge, and then discharge. And Georg would call that SEDS, SEDS, Saturn electrostatic discharge. So he would then record the radio signal from the lightning within the atmosphere. Now, where the amateur data comes into this is that column of material continues to punch upwards. It bursts through the upper cloud layer. Now, this is different stuff from deep within the planet. So I image a white spot. Now, Georg informed me that he was, at this point, so the end of February 2008, he was totally reliant on amateur data. And he had a small team feeding him data on the white spot, where the storm was. That included Marc Delcras in France, Ralph Vandenberg in the Netherlands, Christopher Go in the Philippines, and would I like to be part of this team? Would I what? So from that point on, whenever his RPWS instrument on the spacecraft detected SEDS, he would drop an email to this group with the challenge being to hunt down the optical counterpart to his radio source. So we would all measure the latitude and L3 longitude of the spot that we'd image and send to Georg. Well, only then could he do his analysis on the propagation of the radio waves through the atmosphere, and his field was atmospheric lightning. This same time, I was introduced to Professor Agustin Sanchez La Vega. I didn't know what other people were doing in Australia, but I found an astronomy site, Ice in Space, and I noticed on there this bloke, Anthony Wesley, and he was producing really high-end imagery. And he contacted me, and we became great friends. And he then pointed me to the places that I should upload my data, one of which was the PVOL database, Planetary Virtual Observatory Laboratory. It's funded by Europlanet, and the servers live in the basement of Professor Agustin Sanchez La Vega's university. Agustin is a tenured professor of physics, head of applied physics, and head of the planetary science group at the University of the Basque Country in Bilbao, Spain. I've become great friends with Agustin, and now I've just under 10,000 data sets that I've uploaded to his PVOL database. He tells me that I'm a valued member of his team and that my Saturn work is fundamental to his research.
Amazing. Okay, this is high quality data, and there's a massive difference between taking a pretty astrophoto and gathering valid scientific data for your professional researchers. What strict parameters or capture protocols do you have to maintain to ensure that your data is scientifically useful for the planetary astronomers and academic researchers that you collaborate with? What rules do you have to follow?
Right. Many. So, small scale detail on Saturn is hard to come by. In good seeing, there will always be small scale detail available, but I see so many pretty pictures with Saturn looking beautiful, but totally devoid of small scale detail. And I know it's there. If you get good seeing, there'll be small scale detail there. I suppose images that I produce, you could say, if it's been good seeing, that they are pretty pictures, but they show the small scale detail. Now, movement in this process is absolutely critical. I will never just take happy snaps. I frame my night exactly what I'm going to do. At the moment, I'm only capturing infrared data and methane data. Because of the things that I'm currently tracking, they're the wavelengths that will resolve the features that I track that go into my spreadsheets and drift charts that have done in one instance for over a decade. So this will vary depending on the camera that you have, sensitivity of the camera, and the size of the telescope. But with my telescope imaging train setup that I have, I'm running 9 minutes of infrared, so 6 times 90 seconds, one after the other, to give me a total of 9 minutes with six images, so 6,500 frames each 90 seconds, 72 frames a second. So I will then produce 6 images from those 6 90-second grabs. And then the 6 images are put into WinJupos. They're derotated and merged to the center point time-wise of the 9 minutes. So the detail before the center points move forward, the detail toward the end is moved back. It's an amazing software program. It's freeware. Anybody can access WinJupos. So I do this over at least 2 hours, hour and a half to 3 hours, depending what time of the year this is and how high above the horizon Saturn is for me. But I try for really a minimum of 2 hours of data. So I will have, say 8 infrared data sets at 20-minute centers, and in between those I will have 7 9-minute methane data sets and processed in the same manner. When I first stack my data, I stack my data in AutoStack, and I have AutoStack programmed such that the output of each stack then opens in Registax 6. It's a very old program, so a lot of people nowadays probably haven't even heard of it. But all my computers are old, I'm old, my software's old, and this works for me. And one of the things that it's capable of doing, Registax 6, is linked wavelet sharpening. So I have saved several routines, 7 or 8 routines, to be used with different quality data. So depending on the quality of the data that I'm processing, that'll determine which routine I use. But it will be the same routine for the whole night. Consistency is crucial, that you're producing data of scientific value. So once I've done my first stack that's been sent to Registax, I've applied the wavelet sharpening and I've saved that image. Before I go on to doing the next stack, one of the things Registax can do is image zoom. So I hit zoom image. So that doubles the magnification of the image that I'm looking at, and I apply a very heavy wavelet routine that I've saved, way overcook it. But in doing so, I will then see if within that data, if there's something that I've initially missed that with later processing, because there's much more processing to go than just this, I will be able to eke out because I know that it's there. because I took the time to check in the first instance. So multiple data sets are critical. Movement is key. So I'm very big on animations. Augustine doesn't want the images that I send to him marked up, with me marking where the detail that I see is. Like, I send a detailed report of what is in my data. I make 2 copies of each data run. One goes into a folder that I create an animation from. So all of those images I mark up where the anticyclone vortex that I've tracked since the day it formed in January 2011. And I'm still tracking it, and have just, as I speak to Brendan now, on the 21st of June, I got my first data point for AV for 2026. I'm very excited about doing that. So the images that I use in the animation, I cut just the planet, a little bit of the rings either side out, and I paste that above the image that's going to Augustine, and I shift it up a set number of pixels above the image of the planet. It's in the same position in every data set that I do. Today, last week, last month, regardless of wavelength, the same position. So that means professionals can then can blink multiple data sets from the same night, and they will see the marked up features move in the 2 data sets to make it more easy for them to then identify them in the main image. So it's just one of the things that I do, and I know Augustine loves the fact that I do that, and he's commented numerous times on how meticulous my data is, insofar as the trouble and the time that I go to produce the data that I upload to PVOL. After a 3-hour session, it takes me maybe 7 or 8 days to process that data. And of course, if I have multiple good seeing nights in the between time, well, I end up with a massive backlog. And it all takes time, but I'm prepared to do it. And I know the professionals appreciate what I do because they tell me so.
This is meticulous science. Amazing. Thank you, Trev. Now, let's just take our propeller hats off for a while and talk about your feelings rather than the technology and the science. What goes through your mind when you're sitting at the eyepiece or looking at your screen with the output from your huge telescope? Suddenly you notice a rare dynamic feature, like the storms and the cyclones and the vortexes on Saturn that you found. What goes through your mind when you realise that you're seeing things that no other human has seen before?
Well, if that happens, pure excitement, pure unadulterated excitement. If I'm doing multiple nights, all-nighters, after 3 all-nighters, Cheryl, if she talks to me, probably she doesn't get a response. I'm just a zombie. But when I'm down there and good data's coming in, I'm just alive. To see something no one else has seen doesn't happen very often. On one of Anthony's trips to Broken Hill with his telescope, we were both set up and we were looking at Jupiter. Now, Shoemaker-Levy 9 was a comet that was captured by Jupiter's gravitational field, went into orbit around Jupiter, swung too close and broke into about 21 major pieces. And over 7 or 8 days, they came in one behind the other and collided with Jupiter. And each fireball was like the equivalent of detonating every nuclear weapon on planet Earth simultaneously times about 5. It was incredible to see. Rob McNaught, astronomer at Siding Springs, also that's been out to Broken Hill and visited me. He gave me the predicted impact times, especially for the first one that was going to collide. And that was a thrill. But lots of people were lining up to see that. it was predicted. This night that I'm on about, that Anthony was visiting, he set up where my observatory used to be. I'm upstairs in the 2-story version, and I just finished the blue channel of an RGB run, and I was rotating my filter wheel back to IR, because back then I would go IR, RGB, IR. So that'd be the sequence. Now Anthony, he's a quiet young fella. I like him, and we get on famously. Well, Anthony let out this holler, bellowed out, and I thought, oh, struth, one of the redbacks in Cheryl's garden, he succumbed to a redback, but no. He had witnessed in real time, as it happened, the fireball from an impact on Jupiter. Not one that was predicted that every man and his dog was also around the planet looking at. This was a once-in-a-lifetime event. And he was trying to get my attention to see whether I had seen it. And so my filter wheel was in motion when it happened. So instantly I went back to capturing data to see whether I would get, some after effect. But I didn't. I have a plaque in my observatory commemorating that night, because as far as I know, he's the first observer to see a direct impact on another planet, well, on Jupiter, in real time as it happened, not a predicted one.
Beautiful, such a buzz. Okay, look, you had the opportunity to go and look through a bigger telescope than yours, and they don't get any bigger than the mighty Keck. Tell us about your trip up to the 10-metre telescope, 14,000 feet on the big island of Hawaii. I think that's every astronomer's dream to go there. Tell us about it, Trev.
Oh, what an amazing experience. So again, 2008, I got heaps of publicity internationally and nationally when I found my first electrical storm. NASA acknowledged that, got the invitation to be part of the team, and they went on to put a media release out telling the world about this new storm. At the time, it was the greatest storm that they'd seen at Saturn. In Australia, The Age from Melbourne sent a photographer and a journalist to Broken Hill. The Australian did a full page. In Sydney Morning Herald, they did a full page story on my work for NASA. The lass from The Age, before that was published, she phoned me and she said, look, Trev, a couple of questions, little CV, top right-hand corner. One of those questions was, did I have any unfulfilled ambitions? Did I what? So I said, well, look, I'd love to observe with the twin Kecks, they're 2 10-metre scopes at 14,000 feet on the summit of Mauna Kea, a dormant volcano on the big island of Hawaii. Well, probably more information. My university was Swinburne University. So Swinburne have a supercomputer. Caltech run the Kecks. So Swinburne was, I don't know if it still is, but I assume it is, the only Australian university with a time allocation on the Kecks. I think they got 20 nights to be allocated by astrophysics and supercomputing at Kecks. Well, and the trade-off is Caltech get to crunch data on Swinburne's supercomputer. So my final unit instructor at Swinburne was Professor Duncan Forbes. Well, he contacted me after he read the story in The Age. And he said, Trev, taken 2 PhD candidates to Hawaii. We've got 2 nights on Keck 2. Would you like to come? Well, I had to pay my way, but I got to go to Hawaii with a professional research team, and we had 2 nights on Keck 2. Pretty amazing experience. So all the paperwork that I had to go through before we left Australia, I had to sign a waiver, all the things I could die from, cerebral edema, all these other things, because of the altitude. I mean, if you're at 14,000 feet in an aircraft, it would be pressurized. And also, the information said that as a matter of course, people that summit to Mauna Kea routinely dose on heavy aspirin to thin their blood to alleviate some of these problems, including altitude headaches. So halfway up the mountain, 7,000 feet, is the Onizuka Centre for International Astronomy and a visitors centre. So some of the observatories at the summit, the workers, that they may be working up there for whatever, 4 or 5 days, I don't know, however many days. But if they're working multiple days, instead of going 14,000 feet to sea level and back each day, they actually live in the barracks at 7,000 feet. So, they're going 7,000, 14,000 each day. Not as big a problem with the body. So we stopped there for 2 hours, where I got the heaviest aspirin I could get in Broken Hill. I can't remember now, 200 milligram or 300 milligram aspirin, and popped 2 of them. And then we drove in diesel 4-wheel drives through the cumulus cloud layer. Just think about that. Now, a diesel 4-wheel drive, because funnily enough, internal combustion petrol engines, they don't work real good when 14,000 feet, you're above 40% of Earth's atmosphere. We got out in front of the Keks. Now, beside the Keck on the left is Subaru, famous telescope. To the left of that is the James Clerk Maxwell, which is actually a sub-millimetre radio dish, but it's in an observatory that can open. So then you've got Keck 1, Keck 2, 2 10-metre scopes. There's a tunnel underneath the two with fibre optics and what have you connecting the two, so they can be used as an interferometer to synthesise the aperture from the outside of Keck 1 to the outside of Keck 2. And then there's NASA's infrared telescope facility, and then there's Gemini North, the Canada, France, Hawaii telescope, and then there are several smaller university-run instruments. As I got out of the 4-wheel drive, standing in front of the 2 Keks, the absolute pointy end of optical astronomy on planet Earth, I had tears streaming down my cheeks as I thought of all the people that contributed to that. Kepler, Galileo, everybody who contributed our knowledge in optical astronomy to get to that point. I'll never forget it. It's just incredible.
Fantastic, Trevor. Let's talk now back to your research journey. You've got all this clean data, your reputation has exploded, and you've got a big feature on 60 Minutes tracking your journey from the mines to the stars. And look, I'll put a link to that in the show notes because it's a lovely episode of 60 Minutes, well worth a watch. And during that visit over to NASA's JPL, you got to meet Dr. Carolyn Porco, the legendary Madam Saturn. Tell us a little bit about that journey, that walking into the halls of GPL, not as a visitor in the tourist centre, but as a direct contributor to that mission.
Oh, it's just amazing thing, Brendan. When we walked into Mission Control, the floor of Mission Control, it was actually operational. And the guy who was in charge at that time, he came to meet us. And he said that many times they've had Hollywood production companies wanting permission to come and shoot there to use it as a backprop for a Hollywood movie or something. And he said there's no way they'd have that. But he said he was happy to have us there because of the contribution that I had made to the Cassini mission to Saturn. He said he's more than happy for me to be there. And that made me feel real good. Then later we sat down, and it's just so overwhelming to hear Carolyn explaining to Liz the importance that my contribution had been to the Cassini mission. incredibly humbling to hear that. So we were there in July 2018. Well, they flew the spacecraft into the atmosphere of the planet in September the previous year, so they had no eyes there. And as an aside to this, when 60 Minutes was in Broken Hill in March of 2018, I found a new storm, just a tiny white spot, but was in a place where I hadn't seen a storm before. It was right up virtually on the edge of the North Polar Hexagon, just outside that, which is really unusual. And by the time I flew out in July to go to Los Angeles, it had developed to an amazing structure. And so I put all that data onto a 32 gig thumb drive, and I'm going to show it to Carolyn. Well, we had a NASA media relations gentleman escort us, and he was a very pleasant gentleman. However, we had to remain in line of sight at all times, and when the interview was finished, the cameraman, he was still wandering around taking cutaway shots in mission control, and this gentleman, hell would freeze over that he was letting Trev, the mine worker from Broken Hill, stick his thumb drive in any JPL computer. So fortunately, our producer saved the day and allowed me to use her laptop. So I got to snaffle Carolyn. We went into another room, actually, and I'm showing her this new storm. She doesn't know it exists. How it first formed, my first data point, and how it had evolved over those months. And I'm always getting into trouble because I'm very enthusiastic about my subject, and and a lot of people really aren't interested. But Carolyn, her face just lit up, and she was just as excited as me. And that's a moment that I will always remember, like a kindred soul sort of thing. Oh, it's just a terrific thing. Also, another thing, outside mission control, there are 3 flags. The American flag, the Spanish flag, and the Australian flag. And they represent NASA's Deep Space Network. So Goldstone in California, Madrid, and Canberra, Tidbinbilla. Well, whilst I was in mission control, like kid in a lolly shop, I got to sit in the Cassini mission operator's chair at that monitor. There was a display down the front of the control room, and it had 3 radio telescopes, and they represented Deep Space Network. The prime receiving station of NASA's Deep Space Network was the Australian one, Canberra. How cool is that?
Beautiful. Thank you. That will be going straight to the pool room. Now, you've clearly proven that amateur astronomers can provide continuous high cadence tracking that large professional research observatories simply don't have telescope time for. Now, what advice would you give to dedicated amateur observers now that such powerful instrumentation is readily available and somewhat affordable? What advice have you got to these people with their backyard high quality rigs so that they can contribute to the science community?
Well, I would say one of the first things would be to look, if you're in Australia, check out Ice in Space, Australia's Amateur Astronomy Forum. Have a look around, see what people are doing. Send your data. There's places that you should send your data. So ALPO Japan, ALPO in the US, the BAA in England. All my data, the Saturn data, goes to Mike Fawkes, who's the director of the Saturn section of the BAA. John Rogers, the director of the Jupiter section of the BAA. Anybody can access the PVOL database. I must say now there's a message on the PVOL site. Under no circumstances will they accept data that has been processed in any way with any AI-assisted software. It's got to be real.
Yep.
It's got to be real stuff. I don't have that problem because all of my software is ancient. If some people want to produce pretty images, that should be encouraged. I want to encourage people to look at the night sky. And if some people get their kicks out of making pretty images, that's
And
still
take
excellent.
your kids along.
Exactly. But if you want to go further, you've got to walk before you can run. So if you're starting to use software packages, see what works for you and your data. It's no good trying to use settings that someone uses with a totally different instrument. Work out by trial and error what happens with different processing settings on your data. Build your own knowledge base. That's how you learn.
And build up your hours in your own backyard. Share, learn from others.
When Lee Fletcher used the VLT in Chile to capture the Great Storm in January 2011, and then he wanted amateur visible light data. Well, he wanted visible light data for comparative purposes, and so he trolled through the PVOL database, and he chose my visible light data, which then got officially acknowledged in an ESO media release and in the AAAS Science Journal, because the paper included that image.
Beautiful. Okay, now, in the early days of your work, did you encounter any academic skepticism as an independent observer, and how did you go about earning the trust of the global planetary science community?
Interesting question, Brendan. I must say that in every instance, whenever I've met a professional astronomer, I've never felt that they've been looking down on me. I've been accepted in every instance. First time I met Fred Watson, we visited Sighting Springs Observatory. Fred was then the astronomer in charge, and we were after Rob McNaught, who'd visited me. And we were in the visitors area. You can climb up into a wall of the observatory, and there's a glass wall that you look through, and there's the Anglo-Australian telescope.
The big, beautiful yellow beast.
Yeah, and there is this tall, balding man walking around on the floor. He introduced himself, Professor Fred Watson. And we said, we're after Rob McNaught, and he said, no, he's not here. But then Fred took it upon himself to give Cheryl and I the full tour of the Anglo-Australian Observatory.
That sort of generosity has kept this podcast going for 10 years now. The generosity of the astronomy community, both professional and amateur, I've found has been very warm, and they just love sharing information and data and friendship with everyone. I'm often overwhelmed, and it just keeps me going as well, Trevor. Okay, that reminds me that it takes an enormous amount of patience. You've got to be persistent. Lots of late nights to achieve what you've done. What's a core thing that keeps you going, that helps you to keep that level of independent scientific contribution year after year after year?
Oh, just the passion that I have for what's become my chosen subject. I'm old. I'm rising 3/4 It keeps my brain active. No good vegetating, and that's my chosen thing. I have a passion about it, particularly with Saturn, simply because of the challenge, because it's harder to eke out small-scale detail on Saturn. You have to work at it. You have to work at it, try different things, develop different techniques specific to Saturn, which I've dedicated most of my life to doing.
Okay, they tell us that old people, we've got to get our protein, we've got to have our brains working, and we've got to have sleep. Now, you defy that, Trev. How do you manage your family life, shopping, and doing all the things that you have to do just to get through the week? How do you manage your sleep patterns when you might have 3 or 4 or 5 consecutive nights where you've got this magnificent sky out there for you to grab all the data from? How do you manage your sleep so that your health doesn't suffer?
Well, routinely, I'm in bed by 7 o'clock.
Yep.
This time of year, so winter, like I have dinner. Well, supposedly, every hour before midnight you get is worth two after, so they say. Sort of bank a bit of rest for the next bit of clear weather that's coming, where I'll suffer for 2 or 3 days.
Yep. So you set the alarm for 2:30?
I just wake up. Yeah, I have other problems. Old people get problems, prostate problems. So I told my doctor about this. He says, "Is this a problem?" I said, "No, I use it to my advantage. I have a big glass of water before I go to bed. And then I'm assured of not oversleeping." So it's just, everything works fine.
You're hilarious, Trevor. Fantastic. That's brilliant. Okay, now let's look ahead a little bit for the rest of this year and beyond. What big planetary events and observing projects have you got in your calendar? What are you most excited about to train your beautiful telescope on next? And is there an upcoming event in the world of astronomy or space science that you think our listeners should really be watching out for?
If you live in Australia, the eastern seaboard, then 2028, there's going to be a total eclipse of the sun, and totality is going to last minutes. I think there's going to be people in Sydney that'll think the end of the world has come because the lights are going out in the middle of the day. The path of totality nearly goes over Sydney. Bathurst is a good spot. Burke's a good spot. The track comes in the top end of Western Australia and comes down diagonally across the Northern Territory, bit of Queensland, down into the top of New South Wales, exiting over Sydney. Many years ago, I think I mentioned this in my book, we travelled to Ceduna to see my first and only total solar eclipse. Totality lasted 32 seconds. I always thought, you hear about tragics who follow eclipses around the world, and I think, well, they just bored people. But we went, and I got a aerial map of Ceduna, and I plotted the path of totality, and I plonked our Land Cruiser in the centre of the path of totality, which ended up being the access road that followed the east-west railway line. We saw it, and it was incredible. And if you were blind and you were standing beside me, you would have felt totality, because the temperature dropped like about another 4 or 5 degrees centigrade in that instant. It was an amazing thing. Like, there's all box thorn along this track that we were parked on, and these little birds, they all came to roost in the box thorn where their nests were, because they were...
And total silence. They all get quiet.
It was incredible.
Yeah.
So I think it's very, very worthy of people to plan ahead. And then as far as I go, I thought I was never going to see my AV again. It's really important to me because I've tracked it for so long. And every year it gets fainter and fainter. It's a vortex. It's spinning. It's running out of energy.
An AV...
Anticyclone vortex.
Anticyclone vortex.
Yeah. So because I've got so much data, I have the life of the greatest storm mankind's witnessed in our solar system in spreadsheets and a drift chart. Well, the end of the life will be when this completely fades. Augustine tells me we will publish a peer-reviewed paper, and it'll be the life of the biggest storm by total accident. I imaged on the 21st of June, and I utilised that zoom function that I spoke earlier about in Registax and hit it with a higher wavelet setting, a stronger wavelet setting, and there was this tiny, faint, dark spot far north. I printed out my ephemeris from May to the end of July. The 21st, there was a predicted central meridian transit lined up with the time that I was imaging of my vortex. That caught my attention. So then, that was just in 1/92nd frame, right, of 6. Well, it was in all of that 6. And then the next set, this was the last set for the night. So the start of the night, the seeing was not great because it was lower. And the end of the night, got to 50 degrees, which is not far from the max that it'll be for me this apparition. So 20 minutes earlier, in not as good seeing, it's still there. It's even fainter, but nevertheless, it's there. And in 20 minutes before that, you've got to use averted vision to pick it up. Nevertheless, it's my vortex.
Yep.
So I'm thrilled because Saturn's rising earlier each day. And so now, going forward, say in a fortnight, 3 weeks' time, instead of starting out at 30 degrees elevation, going to 50, I'll be starting out at better than 40 degrees elevation and going to 55.
That's going to keep you going. It's going to keep you, almost keep you out of trouble, Trev. Okay, we've reached the point in this interview where I hand you the Astrophiz golden mic. And the floor is entirely yours. You can address our listeners, the professional astronomy community, or the next generation of backyard observers with whatever message or final thought you'd love to leave them with. What's your message for them, Trev?
Well, I would like to encourage everybody that's an amateur astronomer, that's got a bit of equipment, involve young people. Get involved with your local school. Introduce young people to the thing that we all have a passion about. I didn't mention thus far, but of this little girl next door, Audrey, a lovely little thing. When I found out that I was getting the Walter Haas Award, I was very excited. And they were backing out of their driveway, and I stopped them, and I let them know that in the early hours of the following morning in California, it would be announced that I would be receiving this international award. Well, this little kid, that evening when she came home from school, her and her mum knocked on my door. She had a plate of cupcakes, and the icing was decorated with little gold stars, and she had an A4 lined piece of paper, and she had drawn a cup and put the number 1 on it, and she'd drawn Saturn and the Earth freehand, and she'd written on there, she was so proud to be my neighbour. So I said to her mum, one day, this little girl, she's got to see it. Well, about 3-4 weeks after that, there was a public holiday on the Monday, and I was set up really early afternoon. It had just got dark. And I'm looking at Saturn. You wouldn't believe how good the live feed was. So I rang her dad. So they're coming. So I've put a chair up there for Audrey beside me. Audrey's dad stood behind Audrey. So she's just sitting there. Well, she's just sitting there looking, and when Saturn in all its glory floated, entered stage left, you should have heard this little girl. The response, I thought, how cool. It makes me feel so, even a dad. I mean, they know that I'm into astronomy because they live next door and they see the observatory, but they had no clue what it could do. Yeah. And we all have to take every opportunity to introduce, I'm big on young people, all people, to introduce them to astronomy. I think that's the greatest thing that we could pass on to as amateurs, to introduce others to the same field.
And sharing your great joy with the universe above. Well, Trev, thank you so much for sharing your incredible journey with us, your technical expertise, and the inspiring story behind your fabulous research and the way you challenge and encourage young people to get into it. It's a massive highlight for our year to meet with you in your observatory here in Broken Hill. Thanks for the great welcome you've given us here in your home in Broken Hill. Clear skies, mate.
Look forward to clear skies, Brendan.
Fantastic. And listeners, Trevor's 60-minute interview is on YouTube at tinyurl.com/Trevor Barry. That's tinyurl.com/Trevor Barry. All lowercase, all one word. And if you want to dive deeper into Trevor's incredible journey and the wisdom he's gathered under these outback skies, do yourself a huge favour and pick up a copy of his book, Outback Astronomer. It's a fabulous read, deeply inspiring, and a definitive testament to what dedicated citizen science can accomplish. The book is available online and in all good bookstores. And if you also like to listen to audiobooks like I do, the audiobook is an absolute delight. The narrator is fabulous. You can get the audiobook on Audible, or you can borrow it from the Borrow Box app for free. You can also find full transcripts and images of Trevor's setup on our website at astrophiz.com. Astrophiz is an independent podcast. If you enjoyed today's conversation, the best way to support the show is to leave a quick review on Apple Podcasts or Spotify, or simply share this episode with a friend who shares a passion for the cosmos. Until next time, keep looking up. So make sure you subscribe to Astrophiz, tell your astro buddies, and join us on the 1st of each month for Dr. Ian Musgrave's Sky Guide, so you can plan your observing schedule, and on the 15th of each month for an in-depth interview with another one of the world's leading space scientists. Have fun, clear skies. Radio Wave!